Hello and welcome. Sanjin here with Stuffy, and today we're doing PicoCTF 2022. We're doing challenges in cryptography and web exploitation. Before we get started though, some guidelines. Please try every challenge first yourself. If you solve it, brilliant. If not, your brain is primed to learn. So don't be afraid to be stuck. If you're stuck for an hour or two, that's probably good in terms of learning these concepts long term. And definitely always look for multiple perspectives on each challenge. That's why Stuffy and I do this together. And if you solve this very differently from the way either of us do it, please let us know in the comments. Maybe post your write-up or post a very different write-up. We'd be very interested to hear about those. All right, let's get started. The first one we're doing is called transposition. Now, the thing that I did this time, though, is to make it really exciting. I haven't entered the flags, even though I've tried to solve the challenges. So, transposition-trail. This is what it says. Our data got corrupted on the way here. Luckily, nothing got replaced, but every block of 3 got scrambled around. The first word seems to be 3 letters long. Maybe you can use that to recover the rest of the message. Download the corrupted message here. So we'll copy the link address. I'm just going to do everything in REPL. That is the ciphertext, but just to make sure that, that we're all good, I'll wget the message and make sure that's there. Yep, use wget out and it should appear, right? So that's the message. That it's really weird. So it's got that 4 at the end, but you can already see the flag, right? And so they're saying that if you chop this thing up into pieces of 3, then there's going to be some type of consistent algorithm in terms of how they shuffle. And I mean, there's only about 6 ways you can arrange 3 pieces. So there's basically, in my mind, 6 possible solutions. So yeah, I mean, this shouldn't be too hard. I'm just going to try to make this easy to understand. So the goal is to have a list, and the list is going to be called slices. And this list is going to have the message chopped up into pieces of 3, pieces of 3, pieces of 3, pieces of 3, right? So what we can do is go through the ciphertext for and that's going to be 0 to the length of ciphertext. You want to take slices of 3. So what is that going to look like? If I say a slice is ciphertext and then we say I to I plus 3. And if we print slice, now this is actually not gonna work, but that was my first attempt. So Python 3T transposition. So as you can see, I'm taking slices of 3, but then like the very next one begins from the 2nd letter and so on. So you got to go through the ciphertext by 3, and then that should do it. So let's try that again. So that's the answer. HETFL space, and then it's going to be G space A. Yep, that's perfect, right? So now you can basically say slices dot append slice, and you don't need to print it. And then maybe we can print slices. And the hardest thing is to remember to run it in the thing. So, all right, there you go. That's our list of little slices. And so all you need to do is apply some operation to each slice for slice in slices. Maybe we can have some solution document, solution, and that can be a string because that's what we need. So we need to make the 3rd one first and then keep the 2nd and 3rd. Do you see that? Mm-hmm. So the T and then H and E should come after that. Okay. So that means solution plus equals slices 0. That's going to be the first. So no, slices 2 is going to be the last one, plus slices 0 last, followed by the first, followed by the second. Okay. So that should put the in order. And if this makes sense, then the whole flag may be revealed. So solution up. What am I doing? Go to shell. The flag, the flag, the flag, the flag, the flag, the flag, the flag. Oh, because I'm chopping the individual slice.
Oh,
not the whole string.
Yeah.
All right, let's see. Let me just clear that. And there you go. The flag is PicoCTF 7. Copy. Size you up that way, and paste. Ta-da! There goes the first one. So there goes transposition. The next one is vigenere, and vigenere I'll never forget because I misinterpreted I confused it with the substitution in the last tutorial.
I didn't realize that was one of the ones coming up.
Yeah, but here it is finally. Decrypt this message using this key Scilab. All right. So I'm just going to do everything in that REPL. Before we do anything, you cannot understand vigenere without understanding Caesar cipher. Now, like how often does Caesar cipher come up in CTFs? Because it's like the easiest cipher, but you got to start somewhere.
Yeah, it depends on, I mean, if they're easy CTFs or if they're easy, then they'll do like variations of the Caesar cipher just to try and teach people. But if you're actually doing a serious CTF, you're not going to see a Caesar cipher typically. Unless they're trying to just make you go down a rabbit hole or something like that.
Yeah. For the preparation of this challenge, I'm just going to give everyone like an example of a Caesar cipher. I mean, this REPL is going to be in the description, so I can get away with having one link for all the code. But the demo here is, for example, you will have a particular shift by which everything shifts. So let's say you have a word, like you could say good, and you will enter a shift of 1. So now where you see G is going to be H, where you see O, it's going to be P. So it's going to be H, P, P, and E. H, P, P, E. And this is an example of like exactly how you encrypt. You go shift the letter. This function here shifts the letter, basically. Like that's as simple as it gets. I've done this with year 7 students. The only thing that I've modified that code that I've done with beginners is if I do this, it will still work, right? So it actually, this is important because the cipher, the vigenere assumes that you're shifting uppercase and lowercase. And since we're shifting the flag, and if we mess up the uppercase and lowercase letters, then the flag isn't going to work because it's case sensitive. So like this basically checks if the letter is lowercase, and then, sorry, like if the letter is uppercase, then it makes sure that it prints it back as upper after shifting. And if it's lowercase, it just leaves it as lowercase. Okay, so I think now that we kind of understand what Caesar cipher is, we can move on to the vigenere. And the vigenere is like a Caesar cipher, except that it's encoded with a word, and the position of the letter of the word makes it a different shift. So basically, a vigenere is like a collection of Caesar ciphers. And so we're going to use the shift letter. And if you have some level of misunderstanding at this point about what vigenere is, we're going to like really hands-on test it, and you will understand as we go. But the main thing that you need to understand in the vigenere cipher is that it's going to have a keyword. And the keyword is going to dictate what the shifts are. So in this case, the keyword was Scilab.
Scilab.
So we're going to call that key equals to Scilab. Okay, so if that's the key, then we're going to need a message. wget. And I have a feeling it'll literally be very flaggy.
Yeah.
So we'll wget that. And then it'll ask us, yes. Okay. Yep. It is very flaggy.
Yeah, they always leave those brackets in for you.
So if we go here, I mean, I can just call this cipher text equals to that. Okay, so like, imagine the first one, let's say the word is C. So that means that the first one is going to have shift of 0, 1, 2. So the first letter goes in is a shift of 2. And then the second letter, and you could basically do this by hand. And the second letter is Y. Oh, that's like 25. And the second letter is going to shift 25 and so on, right? However, let's do it with code because that's going to be one, a lot faster. Second, if you ask me, it's a lot more interesting. So what do we need for a function that does vigenere decryption? We're going to need vigenere. I mean, encrypting and decrypting is like plus or minus shift. So like, I might as well just call it, let's just do straight decrypt. But encrypt and decrypt is different by 1 minus. So there's going to be a key, there's going to be a message. And on every, we're going to use that global alphabet up there. Make sure, I mean, if you're doing the code yourself, just copy the alphabet from somewhere. It takes 5 minutes to write it yourself. So that's a solution. And like, let's just do the solution here. That's a string. We're going to need, and now I can do this. And the same thing goes for the last one. I mean, I can use something called list comprehensions in Python. Have you used those before?
I have not. No.
So it's kind of like you, in one line, you create a list using a loop and an operation. And it's sort of doing 3 things in one line. And again, it's not, I don't like it's just not great code. So I'm going to do it in a slightly more complicated way. So we need to keep track of the key index. And we need to keep track of, let's keep that at 0. And also there was a trouble with it because the way that this is going to work is the shifts are going to ignore the actual non-alphabetic characters.
Okay.
So suppose that, suppose the first shift is 2 and the second one is 25, right? If this was a bracket there, not only would it ignore the bracket, the Y would apply to the letter after the bracket. Okay, so let's, so key index, and we may need to extend the key, right? Our key is 5 letters. And I'm just gonna, because you just keep using it key times, I don't know, 100's more than enough. So let's go for a letter in message. For a letter in message, we need a shift. So to determine the shift, we need to get the index of the key letter. So the key index is 0. So key letter equals to key of key index. We can key index plus equals to 1. And now we can basically figure out So what are we shifting? So for a letter in message, we've got the key index, and we're going to need the shift. So let me just shift. Shift equals to alphabet dot index of key letter. So the key is always the key letter is always lowercase. So if this is all we do, I mean, I can just test out that it's at least working. Print shift. And so let's say decoded message, decrypted message equals to vigenere decrypt Scilab. And I think we call this ciphertext. Now, this should give us a long list of printouts of numbers, of shifts that are going to go letter by letter by letter by letter. So Python 3, what's this called? Vigenere. V. And that looks really good, right? So we got shifts of 24. Now,
11. Yep.
The thing is, we're going like I'll happily make the error. The thing that we need to make sure is that the numbers and these things get ignored. So we should have shifts of 0 here.
Yep.
And we don't. We're currently not ignoring it. I guess what we can do is just get it wrong first. So now it becomes pretty straightforward because we've already got the shift letter right here. And we also have managed to get the correct or close to the correct shift right there. So all we need to do is we can stop printing the shift and we can just say solution plus equals to shift letter and letter. And because it's decryption, it is minus shift. And if we were to print decrypted, so that, I mean, that should look, that was deleted, clear Python 3 vigenere.py. Type to string, can only concatenate. Okay. I'm just a little bit worried looking at this. What is it actually? If I print shift here and run it again, where does it fail? Okay, let's just make sure that we're shifting only things that are in the alphabet. I was sure that there's an if statement here, like there, if letter.lower is in the alphabet, but let me double check. Let me double run this. Okay, but the message is none. Four-letter in message. So we're running the ciphertext here. Message is the second parameter. Print shift, comma letter. Okay. And the shift letter returns one more thing. So if the letter isn't in the alphabet, solution. Oh, we're not actually returning the solution. Solution plus equals, geez, man, letter, and then return solution.
Oh, yeah.
All right, that could be,
There you go.
There you go. There is, before we move on, I really want to just basically stress one thing and one place where I was wrong. See that else statement?
Mm-hmm.
The actual iteration of the index should not happen when it hits brackets, right? So what would have happened if we just had this? It's really strange because I had this actually print out a wrong answer the first time I was running it. And that's why I was like, but it usually should read something. And then I had to look at a write-up to be sure that, and yeah, indeed, the write-up showed me an answer that read something. But there it is. I just want to tell people that like the actual index doesn't move when it hits brackets. And I'll just try one more thing here to see if I can get that wrong answer. That was my first answer right there.
Yep.
Right. So
yeah, you can tell because you can tell the brackets are what screwed it up because it has the PicoCTF correct.
Yes.
And then it hit those brackets.
And I'm like, like it just, I didn't want to test it because I want to reveal everything for the first time. I think I might have tested it in the end because I was a bit nervous, but like those brackets there, that iteration of the index right here is what does it. So yeah, that's something. And I don't know that the actual cipher itself has rules of like whether the shifting continues or not. So it's just it either does or doesn't. And I guess if you're in a different CTF, they may not apply the same rules. So
I would say it's probably not, just because when that cipher was created, they didn't really use brackets. So they probably didn't account for it.
Yeah. And like I try to Google, like, do you ignore them? Does it continue? And I got conflicting answers. So that was
well, I've used an online decoder for the cipher, and you kind of had to play with it a little bit to get it to give you the correct answer as well.
That doesn't surprise me.
Yeah.
Okay. So moment of, oh no, that was, I need to rerun it again to get the right one.
Yep.
Don't use vigenere.
That's probably right.
Yeah. Copy.
It's got the name in it.
And submit flag. Boom.
Boom.
All right. So what do I have next here? File run. And this is, I've got a little bit sick of the web shell, and now I'm running my Kali. We've done enough with the web shell, and let's see. File. What?
Oh, it's because you're in cryptography.
All categories. Yep. File. There's probably going to be lots of them, to be fair. File run. And this is a reverse engineering category right here. So, okay, so we're in PicoCTF. I'll make their column. I think there's two of them, so I can just. File. Oh, it already exists. File exists. Okay, wget, a program has been provided. What happens if you try to run it on the command line? I mean, this is like a chmod plus X thing, right?
Yep. Well,
surely copy.
Depends on how you, I'm not a big fan of, well, it's not that I'm not a fan. I don't use the change mod plus X, but it's a good way to do it. I use the numbering system.
Okay.
Just how I learned it.
I think,
it gives you right there.
Yeah. The hints are right there. So like if I go ls run, so obviously this is what they want you to do. Now here's the question that I have for you, right? If I download this again, can you compare the permissions with the plus X and the thing you normally do, the 767 or whatever?
Yeah.
Like if we, all right, let's W get that thing again.
Yeah. So if you just do ls-la.
Cool. Give me 1 second. So how do you want to do it? You want to do
Just
chmod?
ls. Oh, yeah. So you can do it however you want. No plus. It depends on what you're going to do. If this is my personal box that I know no one else is messing with, I'll just do 777. That gives everyone all permissions on it.
Okay.
But this obviously isn't best practice for security, but if it's something that I'm doing for a CTF that I'm not going to ever use again, I'm going to delete it when I'm done. Just 777. That'll give everyone read, write, and execute permissions.
Okay.
And then just the file after that.
Run.1, right?
Yep. And then you'll see the permission difference will be you just added execution permissions. That's all you did. I gave it all permissions. So you can see I have read, write, execute. You have read, write, execute, and then execute and read on the regular user.
Right.
And you can still use the numbering scheme. So like you could still use like 4 is read, 6 is read and write, I believe, and then 7 is execute. So you could still do the numbering system to control the actual ones. The 3 different numbers are the root, the user, and then a guest.
Okay. So what does 7 stand for?
7 is read, write, execute. But the first 7 stands for root. So the root user can do it. The second 7 stands for the regular user can do it. And then the last one is like a guest user.
Okay. And
so you could do like some people do like 766. That'll allow the root user to execute and everyone else to read and write to it, but they can't execute it.
Okay. Which
things like that
defeats the purpose in the CTF.
Yep.
So yeah, let's just run.1. The flag is using your first file.
And what happens is it a binary? What happens if you try to cat it? Just curious what is it?
Cat run.1.
I'm just trying to see if you can even see it in there, the flag.
Actually, strings run.1.
Print flag. Yeah, it looks like I see it right there.
Yep. So you could, you could like stick the strings in a,
you could just strings and grep it for the Pico.
Yeah.
But obviously that's complicating an easy box, but
yeah. Anyway, we have copied it, hopefully, using, and there you go.
Perfect.
All right. File run 2. Here we go. Another program, but this time it seems to want some input. What happens if you try to run it in the command line with input hello? Get the program here. So the hint basically says, just run it like that. So we'll W get it. And I'll ask you something, Stuffy, what's the best way to like rename a file? So if I want to call instead of run.2, I just want to call it run2.
Just move it. So you do MV again.
Okay.
Just run.2 for the file. And then just whatever you want to name it. Next.
Okay. Run2 like that.
Yep. And it just puts it in the same directory.
Okay. And now chmod 777 run2 ls. There it is. So now we're going to run2. So if I just run it, it even tells you what to do with it, right? With one argument. And they said hello, ! And that's your flag.
There you go.
But if I ran it with any argument, won't you say hello to me first?
Okay. Yeah. Yeah. And this is actually pretty common when you're using someone else's tools, is if they don't customize them for you to where they say, what input, what's your target, that type of thing. You have to put some sort of argument for it.
Wow. So first argument. So I was honestly thinking that this was going to allow any argument. Maybe it was going to check that.
Yeah, it just checks it.
But yeah, no, you got to do it. You got to do it their way. Okay. I mean, that was easy. File run, one file run. And this guy, the GDB. Now I installed this thing on my Kali. It doesn't come pre-installed.
Okay.
And the GDB, let's open it up. Let's read it up. GDB. So GDB Test Drive, like the idea behind this is that this GDB is called GNU Debugger. All the tutorials I've seen show examples with C. If I look at GDB, like there you go, you get this GDB tutorial, and all of the instructions, all of the examples, everything involved C programs. And the idea behind any debugger is you step through programs line by line. It's of course, like you need a debugger in a compiled language much more than an interpreted one, like Python. Just do print statements, right?
Yeah.
But the thing is, I couldn't step through the program they gave me here, which, was a little bit disappointing. They tell you exactly what to do. So we're going to download this binary. I'm going to keep it in the same folder. You were going to say?
Yeah, I went through this one too. And I was trying to figure out, kind of like you, I was trying to figure out what's the purpose of this box, right? Because they're giving us the instructions. So you're not necessarily learning anything, but I felt like it's because of the nature of these type of CTFs, these entry-level ones, it's to introduce you to what this is, I guess, what GDB actually is, what a actual debugger is. I think it's so that you then will do some research on GDB and figure out what it is.
Well, I mean, 99% solved. I'm willing to bet that there is an actual challenge down the road where you have to really use GDB, right? Otherwise, it would be pointless. So I'm sure we're going to come across a real GDB challenge. Right now, we're going to do what 99% of people did it to solve it. My bit of research, like I said, is, let me just, Schmods.
Yeah, I'm sure it's going to build upon itself.
GDB me and the only thing is, it's a bit disappointing that the very first file was not something. So like, you can go through the file, you can scroll up and down. And there was a thing like when you're after running it, that was the layout ASM. I mean, you can run it and then that runs the program, but like, and now when you scroll, that happens. You can Control C to exit it. Like, I don't know, running doesn't do anything. You can run it line by line. You can try to step, there's a S command that steps through it line by line. But all of the demos that I've seen on the internet, it's a C program that you're literally stepping through line by line. And like stepping through this, whatever this is not something that quit. Control D. Yes, thank you. So we're just gonna follow the steps now. GDB me. Second step, layout ASM. Third step, break at. Now, this is normally a command that says all, the star. Do you know of another meaning for it?
I don't use GDB, so I don't know what it means here, but usually that's a wild card. So meaning like it's anything before that. But in this instance, I'm not sure if it has some sort of special meaning in GDB.
Main plus. And you follow these genius steps and debugger drive. Thank you so much. Yeah. I look forward to figuring this out. I mean, I don't mind a bit of C actually. That's sort of why
I'm sure it builds upon one. I'm sure there's later rounds of this.
Okay. Exit, Control D. Okay. Clear. So CD, the next one. Third time lucky. Amazing. LS. So we're going to be doing patchme.py. Patchme. Okay. Can you get the flag? There's a Python program and an encrypted flag. This is like we've done similar ones to these. Let's create a directory because I think okay there. Patchme and CD. And then we're going to look at both of them. Copy link address. Sorry. Get the next one. Okay, so there's a Python program and a flag, and let's see what the flag looks like. Complete gobbledygook.
Yep.
And let's see the Python program, nano patch. Okay. The XOR is back. Oh, by the way, I made a YouTube video. Like there's a link. I'll add it about the XORing, going line by line, showing the binary, because I'm up to 11 challenges that include that function. Yeah. So I've explained that on my channel. We can skip past it other than to say that, it basically does the XOR operation on the binary of the string that you put into it.
Yeah. It's the backbone of cryptography. I think that's why they keep doing it, is because you have to have it to do all of modern cryptography. Right.
Okay, so let's look at this thing. There's a flag that's encrypted. They open it. It's a bunch of weird characters. You can't see half the characters.
Equals.
So there's actually, I was going to assemble this, but I wasn't sure about these brackets. And then I thought, welcome back, your flag. I mean, this check, you could just get rid of this check completely. You could just get rid of the if. There's an even better hack. Oops. Did I delete something? Control Z. Sorry. I need to do that. There is, let me in. I was clicking. There's an even better thing.
1 equals 1.
No, like if it isn't.
Oh, if it doesn't, yep.
So all you got to do is get the password wrong now. And
yep.
Oh. Shift Control Z, is that the end? I swear. The mouse free. If it was up to me, I would burn every. Oh, look, it turned. I think that works. So now Control X. Yes.
I was gonna say you can. You have a GUI text editor up top there that you can use.
Which button is it? It's this one.
Yeah, that one right
text
there.
Editor. Yep. Cool. Is there a way that I can get into open a file with it from the command prompt?
Yeah, just type text editor and then whatever the file is.
Okay, I'll do that. I'll do that next time. We've got a couple more coming.
Yep, it'll have to be the name of it. I don't know I think it said simple text editor or whatever it is, but
Python 3. And so that should mean anything.
And we can just get it wrong, and there you go.
That was, that was good. Mm-hmm. There is probably 10 ways to hack your way out of this one. That was very easy. Safe opener. Okay, safe opener. We'll look into that one soon. Safe. Let's clear this. Safe opener. can you open this safe? I forgot the key to my safe. This program is supposed to help me with retrieving the lost key. Can you help me unlock my safe? Put the password, recover it into PicoCTF flag format. Like, all right, copy link address. Okay, actually, let's get out of here. CD and ls. Have we created? I've created safe. So
safe. Yep.
Let's do it again. MK there, SF. I genuinely don't remember this. So let's see. We're in here. We'll wget the thing. Okay, ls. Okay, it's a Java file. And let's try, like, what's this called? Text editor.
Yep.
I'll Google it on the other Kali text editor command. Okay, so we're back, and I actually installed gedit for our file. Let's just show the file. So gedit. That's a bit of a GUI. That'll just save us a little bit of time with modifying and editing this code, right? And this is essentially the safe opener code. And somewhere in here is a flag. So what I'm really looking for is some type of an if statement checking a password. And the closest thing that I could see to it is probably this line right here, right? Now, if I saw equals, I would be confident that this was base 64. Because base 64 is basically just the two uppercase, lowercase alphabets, an equal sign, and some numbers, right? So
yep.
If I copy this.
Yeah.
And
base 64 always adds those equals on the end. That's the telltale sign.
So I'm not 100% sure if this is base 64 or not, but it's my top candidate. Let's see if magic is gonna. Oh, yeah. Please let me into the save. That was too easy. And what does it say? Base 64. Yeah, UTF-8. Yep. Okay. Pico Gym, PicoCTF, curlies, paste, and boom. Yeah, 95% solved, 92 like.
Yep.
Like people like easy challenges.
I
tend to like the ones that are about 60% liked, actually. That's my peak. I tend to hate the ones that 80% don't like, that have low approval ratings. So I think that's the sweet spot. Okay, so that's done. That was easy. Unpackme.py is the next. So let's just exit out of this, maybe check. There's nothing there. MK dir unpack me. And let's go there. And I'm sure there's something to wget, so let's prep for that. And this was unpackme.py. Oh, wow, there's Unpackme as well. 300 points. Interesting. So reverse engineer this Python program. Copy link address. I think this might be, this might be very, very, very interesting. So just so that I have a better, right.
Okay, so the payload's encoded or encrypted.
Now, tell me what you see when you look at this, because this took, this took a while. And I sort of stumbled in by trying to print everything. And eventually, instead of executing, I printed and I got the answer. But like,
okay,
how often do you see this type of thing? Because it seems to have like, if I didn't know that exec is a function that's going to have code within it, right? Sometimes you can print what's in there, sometimes you can't, but given that it says the code, That was my strategy. I'm like, print everything. And eventually I stumbled across it. But how often do you actually send encoded code in this manner?
It's actually super, maybe not this specific manner, but it's actually super common to encode payloads.
Right.
It's probably the number one way to evade intrusion detection systems and things like that. And that's just because, so the way 99%, I would say, there are variations, but the way that most antivirus and intrusion detection systems, intrusion prevention systems, firewalls, all that stuff, most of them use what's called signature based. So it's someone downloads a payload and tries to use it on your system. You already know that payload exists and you have the hash sitting there, and it comes in and says, oh, that we know that's a bad file. So no. Then there's also, behavioral, where they'll look for certain types of programs that run in sequence and stuff like that. So the more you can convolute your code, the more likely you are to get through things. So if you have something that's going to run a malicious file, you might have it run 10 good files first so that it doesn't look like it's doing anything wrong and stuff like that. It's just, hackers get really creative with the way they'll try to evade, and encoding is definitely one of the, encryption is really good too, but you have to already have an encrypted tunnel with them to do that.
Cool. So I've just printed everything that looked printable, and now we're going to run it.
There you go.
And so first I just got some, essentially I'm printing out the program, which checks if this is the password is battery horse. I've went ahead and looked if anybody solved it any different. I have no idea how. Oh, because I printed the print statement, and everybody essentially did some variation of what I did. I thought that somebody would have entered some password or something like that.
You could definitely brute force it, but when it's that easy to bypass, you would just be kind of wasting your time, because you'd be sitting there for a little bit while it's doing it.
Yeah, there you go. You could see the password. So that was all right. I think the next one's going to be my, bloat. This was potentially my favorite because it was sort of harder and I was able to solve it reasonably quickly. And then I looked at how other people solved it, and nobody did exactly the same thing. Some people really overthought this one. So have you seen it?
I haven't seen it, but that happens a lot. People overthink it and they kind of spend more time than they needed to on a lot of these.
Yeah. All right. Let me show you this. I can't wait. So I think I have it here. No, actually, make their bloat. CD bloat. Okay. Let's take a look at it. Now, there was something really weird because I've had it work in one editor correctly and not in another. So I could have ended up spending 77 liked. So can you find a flag? Run this Python program in the same directory as this encrypted flag. All right, copy link address. Get that. And copy link address. Get that. And here we go. So that's cat flag encrypted. Yep. The usual. There's a whole bunch of invisible characters here because that's what happens like when you sort of XOR your way through, and then there's going to be, let's go gedit bloat. And look at that. Now, if you look at this, right, A is some collection of characters, isn't it? You got the whole alphabet, uppercase, lowercase, you got all the numbers. You got it's like an encoding table, right? And look at that. That's a string. That's a string. That's a string. That's a string. Yeah. That's a string. So like, instead of, there are people, I started to do that actually. I started to, because I couldn't get it inside Kali. And so I started to start naming these functions to figure out how the code works. I mean, I guess that's what reverse engineering is, right? So I was like trying to get the function name by function name by function name to work out what they do. Because I couldn't get the answer just by printing strings. And then for whatever reason, I decided to try it in REPL, and then I could get the answer. So it was weird. So like, this is what I did. And this is what I was very proud of, because people overthought it. I'm like, I'm just going to print everything that looks printable. And, that could be a flag, or that could be a password. That could be something.
Yeah. Something.
So there's another print statement. Make it unconditional, right? So you're just printing everything that can be printed. Forget the functions, forget in which order they run.
Yep.
Okay, so this is something argument 444 decode. Unfortunately, I can't print the decoding of that, but that might be some kind of encoded something.
Yep.
I can still try to print. This thing doesn't have bracket closing, so
no, it's not auto.
What is when they say plus dash? Like, what is, and then you start a new line? Shift Control Z, is that undo here? Nope, Control Z. Thank God for normal Control Z. There you go. So I'm just going to delete that, add a print statement. Never mind that. I'm just going to print that. And
I'm assuming by the name of Bloat.py, there's a lot of wasted printing here, is what I'm assuming.
And again, zip turns like two elements into a tuple. So it could be two lists into like a thing where every item is now a tuple. It's used with list comprehensions as well. And this is the XORing bit. So unfortunately, there's nothing I can print here because it uses all the functions. So that's where I ended up. And I thought this was going to reveal something. I'll click save here, and we'll go back into my, why do I gotta?
It's because it's still running gedit.
Okay. So ls Python 3. Now,
happy chance that password rapscallion.
See, it looks like it checks if the password is happy chance.
Yep.
That's what it looks like.
Or rapscallion. I don't know.
So let's.
Or they're calling you a rapscallion. I don't know.
Let's try both. Let's try both. So the only thing is, I think I got to MV Bloat.py into the decoded .py, right?
Yep.
Is that, will that do? Will that rename it?
Yep. That'll rename it. Yep.
Okay.
Now you have to re-download it.
And I got to wget. Oh no, was that the flag again?
Yeah, you just re-download the flag.
Python program, copy link address, wget, boom. Okay, so now if we Python 3, the bloat, and
what was it? Happy
chance and rapscallion.
Which it sounds like they're calling you a rapscallion if you get the password wrong, but
okay, let's go. Happy chance.
There you go.
Now it worked. I have no idea. Like so what had happened to me is that this hadn't worked. Actually I got the curlies, but I had it seemed to have like every fifth character wrong, and I just couldn't work it out. And then I just did the same thing in REPL, and then it worked. I probably just added like some tiny thing somewhere in
it might have been
in the editor.
Yep.
But yeah, that was out of the lot. This was by far my favorite, quite simply because the whole challenge was setting you up to essentially scratch your head for 2 hours renaming functions until you've actually figured out what they do. And I was like, yeah, nah, print everything printable. And that got me through like.
No, that was a really cool way to do that. I wouldn't have done it that way just because I wouldn't have thought about it, but that saves you so much time.
Yeah. So I think, that's like my current peak CTF moment. Because, when you're a relative novice compared to the people that do the write-ups, and then you're going like, dude, I did it 5 times easier than you. Like when you actually see the write-ups that's, I really get a kick out of that. Okay. So that's all from my end.
All right, guys. So today we're going to be doing the web exploitation for the PicoCTF 2022 challenges. We're going to cover today includes the inspect HTML, the local authority, the search source, and then the SQLiLite. And the SQLiLite, I'll tell you guys, I'm not sure why it's worth 300 points because I think it's probably one of the easiest SQL ones we've done, but that's just me. So all right, so these are the 5 we're going to cover today. So we'll go ahead and start with includes. It's 100 points. Looks like 96% of people attempted it and solved it. So we got to go to, let's see what the hint is. Is there more code than what the inspector initially shows? Okay, so go to the website. We can say hello. And the code is in a separate file. Okay, so that's kind of a dead giveaway. Because that means if we go to sources, we know there's other files. Okay, so you can see we've got part of a flag. We don't have all of it, but we've got part of it. This code is in a separate file, okay? Okay, and there's the rest of it. So let's go ahead and copy that first. Then we can go back here. So it looks like we got 1 of 2. And then we can go back here and get the rest of it. Now let's see if that works and if that's all the code. Boom. Okay, so that one was pretty easy. All right, let's go into inspect HTML. If I remember correctly, I think this one's similar. Let's see. All right, so can you get the flag? Go to the website. Let's see what the hint says. What is the web inspector in web browsers? Okay, so they want us again to look at the web inspector.
On hiatus.
Okay, looks like kind of a similar web page. It said Wikipedia. Oh, I looked at the page source, which I saw it in there, but I want to look at the inspector. Okay, so inspector, you can see it's actually a note here. So that's pretty easy. We have that.
Comment, HTML comment.
We'll just copy it. Let's see if it'll give it to me or not. I don't know how it's going to paste here. Let's see. Okay, it did. Perfect. Okay, so it's just a comment. So they just accidentally left it in. Perfect. Pretty easy. So that actually does happen in the real world. A lot of admins will be, building a website or web designers and things, and they'll leave comments in there and they forget to take them out. And now it's not usually always like a password or something, but it's kind of a hint sometimes like, hey, I got to make sure I update next week or something like that and they might be saying that to someone else that's going to be looking at the code. So, and then that tells us they're on a actual version that's not updated all the way. So, all right. So we're going to search source. So search source, we go to it. The developer of this website mistakenly left an important artifact in the website source. Okay. How could you mirror the website on your local machine so you could use more powerful tools for searching? So I don't think we have to do that here, just because it's not a large website, if I remember correctly. But you could actually save the website and then actually search it. But if I remember correctly, we can inspect it. And I think if we go to sources, we start seeing some sources that we can look for. Okay, I don't see anything right off the bat, but let's see. So if we do this, we know that the flags start with PicoCTF. Mm-hmm. So we can go ahead, Control F, try and find it. It doesn't look like anything's in that one. Let's try this one. I don't think anything's in that one.
It's not going to be the keep going. Not going to be the images. This.
Oh, here we go.
Oh la la.
So again, it's a comment. Banner main, PicoCTF inspection of web pages. Okay. So this is another example where there's multiple ways to do this, because the hint they gave you is basically to download this source code so that you can then control F and find it in your own tools, or use some sort of tool that's going to systematically go through and do that. But since it's a relatively small website, I mean, it's not that difficult to manually do this process, especially since they left it in the first 4 files. So let's go ahead and enter it. Boom. Perfect. Okay, let's see if local authority is up.
Nah, I
would
tried.
say probably not. Oh, you did?
Yeah, I mean,
okay.
Cool.
All right. So this here, we're doing SQLiLite. Looks like 99% of people have solved this, but it is a 300 pointer. So this is probably one that a lot of people are going to try. All right. So we have a username and a password login. Let's go ahead and inspect it first, because I want to see some of the other sources and what it's doing here.
So there's a
all right. So these are just CSS. Okay. So this isn't, so it looks like we don't have a lot here, but let's see. Input type. Okay. No big deal. All right. So the one thing I noticed about this specific CTF over some of the other ones we've done with the SQL is they didn't give us a filter. If you guys remember some of the other SQL ones we did, there's a filter page.
It does say admin is the user you want to log in as, I guess.
So let's obviously just try admin, right? So let's try admin, and then password. We'll just do password because sometimes that's the default password. Okay, login failed, but we see that there is a login PHP file.
Wow.
Okay.
How often? Like, here's the question that I wanted to ask, right? I mean,
yeah,
like we've seen these before. So if you're trying to access a SQL database and doing so via login, like, when do you see this? When a developer is testing the stuff and then they're doing print commands, like.
Yeah, you would never, I won't say never. You would, as a user trying to log in, you would never see this command. This command would go to the back end. So you would, go ahead.
The question I have, is this the equivalent of me doing print statements in my Python program all the time to see how it's processing input and if it's doing the right thing?
Sort of. Yeah. So yes and no. So the reason I say yes is because that's what it's doing here. It's showing you what it's doing. But the reason I say no is because you won't ever see this. You just have to, so the easiest way to do this, and I've seen some other people do this. I meant
like if I'm a developer and I'm testing my portal, I'd be printing that stuff. Yeah.
If you're a developer, this would be an easy way to validate yourself too, because if you're trying to check for a SQL injection, you can just do it. And then you'll say, okay, so that's the command it's running. Okay, cool. So blah, blah, blah. So yeah, this would be a very easy way to check yourself, basically, like you said.
Cool.
But yeah, in the real world, it's never going to print the statement for you. There is ways to get to see what's going on. You can get error codes. So like sometimes you'll get where, in one of the boxes I did on PicoCTF, actually, you get an error code, or you go through and see an error code, and the error code says SQL error. So that tells me, okay, they're using a SQL database. So now I know what language to use. So what you're doing, why they're giving you this is obviously to understand it. But typically, if you know they're using a SQL database, then if you understand the language, you already know what it's trying to do when it logs in, because this is a very common statement. It's going to say select from the users, and the users of the table, where the name equals admin and the password is admin. So this and statement's the important part here. This tells us that the username has to be admin and the password has to be whatever the admin's password is. It's going to check both those parameters.
So even as a novice, like I already get that the idea is to basically hack the statement where this check here, which is the logic of the program itself, somehow gets ignored. Somehow we want to select the name admin, but never mind the password being password.
Forget the password. So there's multiple ways of doing this in SQL injections. A lot of times, like what people do is they'll put 2 dashes here, and that's a comment. And so like you can see here in my, where username equals admin, and then we would do two, I can't type in there. Oh, well, we would do 2 dashes. And what that's going to do is comment out the rest of this and statement. The problem is a lot of, especially nowadays, you know, this is known that it's that easy. So a lot of people will have what's called validation checks where it won't allow you to input that type of character. When you put it in, it's just going to filter it out. It's going to say, we're not taking that, whatever. So you have to start thinking outside the box. What other statements can we use? We could use an or statement. So what that means is we could finish this right here by typing admin with the comma.
Why don't we try that super basic comment out? The password is password, and just show that. And like, you know, let's just show it fail.
Yeah. So admin. So here's the admin, and you put that comma because if you guys remember, we'll go back forward. So if you remember, so this right here, all this is pretend it doesn't exist. And this is the statement you have right before it. And so we type admin, but if we just leave it at admin and hit enter, it's automatically going to fill this for us because that's what the code says. So we have to put that comma. So then we can start typing past and keep the actual statement going. So then if we hit the 2 dashes there, that now is telling it to comment out whatever's after this. So the password won't matter. We can type whatever, it doesn't matter. Now, when we hit login and you see it worked. So you can see now the statement says name equals admin. And then there's our comma that we put in there. And then the 2 comments. So all of this isn't read anymore because it thinks it's a comment in the code.
Wow.
So now it says, now you can log in, but can you see the flag?
Is it highlight the page?
Nope. So if you remember one of the ones we had before, you could just highlight it. We can't do that here because it is actually in the code.
Right.
So paragraph hidden, your flag. Yep. PicoCTF looks like you solved it. So yeah, this one is a pretty basic SQL injection. It's extremely basic, and scarily, there are still sites out there that this simple SQL injection works.
Wow.
So, boom, and there you go. And that's worth 300 points.
Okay. Well,
I doubt this one's up.
At this point, I think, yeah, I've never seen them come online in like a short period.
Yeah.
The other one that didn't work was Forbidden Paths. I don't know if it works for you, but yeah. Let's see if it's back on for me.
We did Forbidden Paths last week.
We did it last week, but yeah, it doesn't work either.
Yeah.
So
this. I was just taking a note down that one we couldn't do that one.
All right, everyone. So we're going to stop here with this video. It's a slightly shorter one. And what we're going to be doing in the very near future, keep your eyes peeled, is, I was trying to click on your screen. What we're going to be doing in the very near future is going to be forensics and binary exploitation. And like my favorite challenge so far probably has been the flag shop. And I think that's the example of binary exploitation. It's the way the data is structured, and you can try to find integer overflows. And there's a lot of very interesting stories of people buying stuff and getting refunds at the same time, and getting a lot of game currency using that. So it's a fun real world hack that. So yeah, join us for that, and see you very soon. Bye-bye.